Welcome to the video on vectors, displacement, position, magnitude, and more. First, we'll learn about what a vector is. So a vector can be denoted like this with a little arrow on top of it if you're writing it by hand. And a lot of times when typing it, it'll just be a bold letter. And it's an object with magnitude and direction. So a vector is a little arrow, and it's important to know the magnitude, which is the length, and the direction, so the angle that it's pointed in. The base vectors are 1 unit long along each of the 3 axes. So this is your I vector is 1 unit in the x direction, your j vector is 1 unit in the y direction, and then your k vector is 1 unit in the z direction. So your components of a vector, your vector equals your x component, your y component, and your z component. So it would be some number v1 times the direction it's going in, your I direction, plus v2 times the direction it's going in, which is your y direction, and then v3 times k, which is your z direction. The 0 or null vector is a vector where the magnitude or length is 0. So essentially it's just a point because there's no length to it. The negative vector, negative v, is a vector with the same magnitude as v but in the opposite direction. So if this is v, then this vector here is negative v. So we can find the sum and difference of vectors. To find the sum, you'll add separately your x, y, and z components of each vector. So a plus b, if this was your a vector and this was your b vector, you would add your x components, your y components, and your z components to get your c vector. So a plus b, graphically you could move the end of one to the tip of the other, and then you can draw your c vector. So if we took our a vector and moved it up here, then you would have this line here so that you can draw your c vector. You could also do it from a to b. To find the difference, you subtract the x, y, and z components of each vector. So a minus b would be your x value of a minus x of b, y of a minus y of b, and then z of a minus z of b. So graphically, this would be your a vector and then the reverse of your b. So if you're adding, you would go this way, but since we're subtracting, we're going to go down, and then you can draw your c vector there. For multiplication by a scalar, you'll multiply each component of the vector by the scalar. So if you had some number k times your vector, you would do k times your first component, comma, k times your second component, comma, k times your third component. If you can multiply a scalar by a vector to get another vector, then that means that the two vectors are parallel. So if k times v equals some vector a, then v and a are parallel. So next we have magnitude and unit vectors. The magnitude of a vector, you can write that by doing a bar and then your vector. That's how you write the magnitude, and that's the length of a vector. So that would be the square root of all of the components squared added together. The unit vector is a vector that has a magnitude of 1. So if we had some vector v, we could find our unit vector by taking that vector and dividing it by the magnitude. So for example, if we had a vector 2, negative 1, 6, we could find our magnitude of v, so this is vector v, will equal the square root of each component squared. So 2 squared plus negative 1 squared plus 6 squared, which is the square root of 4 plus 1 plus 36, which equals the square root of 41. So that would be your magnitude. So your unit vector, which is this little caret on top, the little hat, that means it's a unit vector. So this would equal our original vector, 2, negative 1, 6, divided by the square root of 41. So you'll divide each component by the square root of 41. So this would be 2 over the square root of 41, negative 1 over the square root of 41, 6 over the square root of 41. And then you would get rid of the radical in the denominator by multiplying by the square root of 41 over the square root of 41, which equals 2 root 41 over 41, negative root 41 over 41, and 6 root 41 over 41. So that's how you find the magnitude and the unit vectors. Finally, we have position and displacement vectors. So a position vector is a vector that gives a location with a reference to another point, which is typically the origin. So if we had that vector A equals 2, 3, you'd go over 2, up 3. So that's where point A is. And then from the origin to A, this would be your vector. And that's the same thing if you had some point B. So if our point B was at negative 3, 2, then B would be over here. Negative 3, 2. And then a displacement vector is the shortest distance to a new location. So AB would be the distance from A to B. So it would be B minus A. So graphically, we would take A and move it over here. And then since we're subtracting, we need to flip it around. So it would go this way. So your resultant vector would be here. That would be C, which is your AB vector. So that would be the distance between the two, your displacement. It would go right here. So if we had a vector where we had 5, 3, and that was A, so there's our position vector for A. And then if B was 3, negative 2, then AB would equal B minus A. So 3, negative 2 minus 5, 3. So that would equal 3 minus 5, which is negative 2, comma, negative 2 minus 3. So negative 5. So negative 2, negative 5. So this would be your distance vector or your displacement vector. And if you put that here, that would be the same thing. So now we have our first IB practice question. It says, given V equals 1, negative 2, square root of 11, express the vector using unit vectors. So we want to use our I, J, and K. So this would be 1I, so just I, plus negative 2j plus square root of 11k. So V equals I minus 2j plus the square root of 11k. Next it says, what is the magnitude of the vector? So our magnitude of our vector equals the square root of each component squared. So 1 squared plus negative 2 squared plus the square root of 11 squared. So that equals the square root of 1 plus 4 plus 11, which is the square root of 16, which equals 4. So the magnitude of V equals 4. Finally, it says write V as a unit vector. So V with the hat, our unit vector, equals the vector divided by the magnitude of the vector. So that equals 1, negative 2, square root of 11, divided by 4. So you'll divide each component separately to get 1/4, negative 2 over 4, which is negative 1/2, and then square root of 11 over 4. So this is your unit vector for V. You can check this by finding the magnitude of your vector and making sure that it actually is equal to 1. So to do that, we would do the square root. So the magnitude of our unit vector equals the square root of 1/4 squared plus negative 1/2 squared plus the square root of 11/4 squared equals the square root of 1/16 plus 1/4 plus 11/16. So we need a common denominator, so we'll multiply this by 4/4 to get the square root of 1/16 plus 4/16 plus 11/16. 1 plus 4 plus 11 is 16, so we get the square root of 16/16, which is the square root of 1, which equals 1. So that means, yes, we have indeed found a unit vector. Now we have our second IB practice question. It says, given that A equals -4, 1, 12, and B equals 2, 5, -6, find 1/2 A minus 3B. So we need 1/2 A, which is -4, 1, 12, minus 3 times B. So 3 times 2, 5, -6. So this is similar to the order of operations that you use with normal algebra. So we'll need to multiply these in before we can subtract. So 1/2 times -4 is -2. 1/2 times 1 is 1/2. And 1/2 times 12 is 6. Minus 3 times 2 is 6. 3 times 5 is 15. And 3 times -6 is -18. Now we can go ahead and subtract. So we'll do -2 minus 6 is -8. 1/2 minus 15 is going to be 1/2 minus 30/2, which is -29/2. And then we have 6 minus -18, which would give us 6 plus 18, which is 24. So this would be your answer here. And this vector here is parallel to this vector because you can multiply it by a scalar to get to it. And then this vector here is parallel to this vector here. Just another side note that's important to know. So in summary, vectors are objects with magnitude and direction, like this. Base vectors are vectors that are 1 unit long along each of the 3 axes. So your x unit vector is I, your y unit vector is j, and your z unit vector is k. The components of a vector can be written like this. Your 0 or null vector is a vector where the magnitude is 0, so it's just a point. Your negative vector is a vector with the same magnitude as a normal one, but in the opposite direction. So your negative vector of this would be one like this, and they'd have the same magnitude. To find the sum of vectors, you'll add the x, y, and z components. To find the difference, you'll subtract the x, y, and z components. When you're multiplying by a scalar, you'll multiply that number by each of the different components. The magnitude is the length of a vector, so you take the square root of each component squared. A unit vector is a vector that has a magnitude of 1, so you'll take your original vector and divide each component by the magnitude. Your position vector is a vector that gives the location with the reference to another point, typically the origin. And a displacement vector is a vector that shows the shortest distance to a new location. And that will show your distance and direction because it's a vector. That's all for this video. Thank you for watching.